Has this ever happened to you? You check the weather forecast, it predicts rain, and then you end up carrying your umbrella around a beautiful sunny day. With that said, my topic is weather prediction. Weather is an extremely complicated phenomenon made up of hundreds of different factors and variables. And simply keeping track of it is a rather daunting task, whereas making a correct forecast is a totally different beast. These days, weather forecasts are made by supercomputers solving insanely difficult and complex mathematical equations. Those equations can be drastically different depending on the region, its terrain, its man-made objects, and other inputs. Yet, meteorologists still have trouble correctly predicting the weather over a few period of days. Sometimes they don't even get it right for over a 24-hour period. Why does this happen? In order to answer this question, we have to look into a scientific paper published nearly 50 years ago titled "Does the Flap of a Butterfly's Wing in Brazil Sets Off a Tornado in Texas?" Yes, we all know it. It is the popular butterfly effect, aka chaos theory. The basic idea here is that even tiny, seemingly insignificant choices you make can have a huge consequence on in the future. Why is this relevant to weather prediction? The answer is that it gets at a fundamental question: how well can we predict the future? Chaos theory really came into focus in the 1960s when meteorologist Ed Lorenz tried to make a basic computer simulation of the Earth's atmosphere. He had 12 variables and 12 equations, things like temperature, pressure, humidity, and so on, and the computer would print out each time steps as a row of 12 numbers, so you could watch how they evolve over time. Now, the breakthrough came when Lawrence wanted to redo a run, but as a shortcut, he entered the numbers from halfway through the previous printout. And then he sets the computer for calculating, and then he went off to get some coffee. And when he came back, he saw the results. Lawrence was stunned. The new result followed the old one for a short while, but then it diverged, and pretty soon it was describing a totally different state of the atmosphere. I mean, totally different weather. Lawrence's first thought, of course, was the computer. The computer had been broken. Maybe a vacuum tube has blown, but none had. The real reason for the difference came down to the fact that the printer rounded off to 3 decimal places, whereas the computer calculated with 6. So when he entered those initial conditions, the difference of less than 1 part in 1,000 created a totally different weather in a short amount of time into the future. This is why these days it is done using supercomputers, and it is extremely difficult since you have hundreds of variables to keep track and you cannot round it off. So where do meteorologists get their information to predict the weather? Today, weather forecast or meteorology relies on big data and big data collection networks. This network includes land-based weather stations, weather balloons, and weather satellites. Weather forecasters also use the data from offshore buoys and ships operating at sea. All of these sources combined create an observational network of data. This data is entered into computers to create a computer model. Meteorologists use this computer model to make weather forecasts. Weather stations are more often located in and around the cities. As a result, there is often less data available from rural regions and marine areas. Also, weather stations from major airports and cities may not be as accurate as those in more populated areas. This is because rural weather stations are more sparsely placed. They might not be able to provide accurate data for a large area. Meteorologists often use satellite data to fill in these gaps, but there are things that can reduce the accuracy of satellite data. For example, include cloud cover and changes in the amount of water vapor in the atmosphere. Let's talk about the weather models. Weather models use mathematical equations to analyze and predict atmospheric processes and changes. Weather models use a simplified picture or a grid of the land surface. This is similar to a route map or a topological graph. For example, sometimes the resolution of a weather model uses a grid size of 12 kilometers. This means that each point on the model represents an area of 144 kilometer, which is 12 times 12 kilometer or larger. If the grid size was smaller, then there would be more data points. For example, imagine a 100 kilometer with a 10 cross 10 kilometer grid size. This gives more accurate model of what will happen. In some places, the land shape and surface features were fairly constant over a large area. In these places, having a large grid, which means low resolution, is not such a big issue. But in regions where land features change a lot over a short distances, low resolution can cause large errors. Now let's look at the models that are currently in use. The first one is ECMWF, European Center for Medium Range Weather Forecast. The ECMWF is a European global forecast seamless model, and it is widely regarded as the best and the most reliable model currently in existence. It uses a concept called 4D, which is an assimilation that allows the model to be constantly updated as the new satellite or other input data becomes available. It is well-known fact that the ECMWF was the only model that accurately predicted where the Hurricane Sandy was moving. The second one is WRF, World Research and Forecasting. The WRF was a result of a collaborative effort of several agencies and laboratories across the globe in 1980s. It is a code base for further forecast model processing. It is applicable globally and can take local geography and topology into account. It has a wide range of different physical parameters and demand vast resources to process. Many institutes use the WRF as a base to develop their own regional models. And few other examples are GFS and ICON, which you can look into. So how much can models really predict? Weather model is only representation and approximation of the reality. They do not account for all the variables that may affect the weather, and researchers are still learning about many of the processes that affect the weather. The accuracy of the weather forecast will continue to improve. That is because the computer storage size and speed increase. Weather model will be refined, the observational network that supports weather data or expanded. But no matter how complex weather model become or how much observational network expand, meteorologists will always make forecasting errors. The instrument used to measure the weather-related variables will always be imperfect. Earth's atmosphere is highly complex. It will always be challenging to fully simulate in a weather model. So no matter what the forecast says, it never hurts to carry a raincoat. Thank you.